In this video, we are going to talk about the gases law and the relations between the volume, pressure, and temperature in gases, and see what they have. What are these elements can be changed if we change one of them or another. So let's look at the first relation. The first relation is that volume is proportional to the inverse of the pressure in a gas when the temperature is constant. So this is the one point that we need to know. So temperature is constant and the volume is proportional to the inverse of the pressure. This makes sense, right? When the temperature is constant, if we increase the volume for a fixed amount of gas, the pressure will decrease. So if we want to plot this graph and show it in a graph, here is pressure, here is volume, we will have something like this, right? Okay. So the other thing, the other relation is that it is the Boyle's law. Boyle was a scientist and he found out that pressure times volume in the gases will always give constant value when the temperature is constant, of course. Okay. Another relations we can find is volume and temperature are directly proportional when the pressure is constant. Also, pressure and temperature are directly proportional when the volume is constant. Okay, and if we want to plot these relations, volume and temperature on a graph, let's say this is our graph. The horizontal axis is temperature and the vertical axis is volume. Scientists have found that when the pressure is not too much, okay, when the pressure is not too high and it is kept constant, the volume of a gas increases with temperature at a linear rate. So we will have something like this, right? They will have linear relations. And if we decrease the temperature, at some point, this line will intersect with the horizontal axis and the volume will be 0. This temperature is 273, minus 273 Celsius degrees. And that's where the absolute 0 temperature comes from, right? And if we look at these relations, they make sense. Why? When we increase the volume for a fixed amount of gas, the temperature will also increase, because when you increase the volume, you are making much more space for the molecules of gas to move around, vibrate, go around. So that's why they will have much more movements and space to move and this will cause to have higher temperatures. And when we look at this second relation, when we increase the temperature, the pressure will also increase when, of course, the volume is constant. Okay, after learning those relations between the volume, pressure, and temperature in the gases, we want to summarize all of them in one relation. So, and that relation is this. In this relation, if we, for example, keep volume constant and increase the pressure, the temperature also has to increase. Or we can say, if we want to keep the temperature constant and increase the pressure, the volume has to decrease in order to have a constant temperature. It makes sense, right? So this is very useful relation to know how these three variables are related to each other in the gases. More experiments also showed that P times V will have directly proportional relation with M times T, where M is the mass of gas, which is in gram. And more experiments also have shown that P times V will be equal to nRT. This time, it is important to note that this is equal. Okay, this is equal. So we need to pay attention. Not like this, not to be proportional, right? So N is the moles of gas. So of course it will be in mole. And R is universal gas constant. It is a constant, it is a number. And T is also temperature, which is in Kelvin, right? So we need to understand this. So what is R? Well, scientists in the experiments have known that the R is constant for any gas, and its value is 8.314 joule per mole times Kelvin. Okay. And it is very important point to note that this equation is only true for ideal gases. This is true for ideal gases. So the normal gases that we have in the world will behave like ideal gases if the temperature is if the pressure is less than an atmosphere and the temperature is not close to the liquefaction point of the gas, then the gases the behavior will be like the ideal gas. So we can use this formula. So this is very important to note that we cannot always use this equation. It is not always true. But if those criteria are satisfied, then we can use of this we can use this equation. In the next slide, we will go to solve some of the examples about this concept. In this example, we are asked to find the volume of 1 mole of gas which behaves like an ideal gas at STP. Well, STP is the abbreviation of standard temperature and pressure. So what does standard temperature mean? Well, the standard temperature is when the temperature is 273 Kelvin or 0 degrees in Celsius. And the standard pressure is 1 atmosphere, or in another way we can write it as 10 to 5 newtons per meter square, or we can write it as 100 kilopascal. So these are very important things to know. What do we mean by the STP? So we're asked to find volume, and it behaves like an ideal gas, so we can use that important formula for the ideal gas. So what is it? It is PV equals to nRT, and we want to find the volume. So V will be nRT over P, which is pressure. So this will be equal to N is 1 mole, R is 8.314 joule per mole times Kelvin, and the T is 273 Kelvin, and the pressure which we want to find, it is better to use this one. It is 10 to 5 newtons per meter square, right? So if we calculate these values, we will get 22.4 times 10 to power minus 4. Minus 3 meters cube, and which is 22.4 liters. So it is very useful and important information. This number is it's widely used in the gases, in the ideal gases. So it is better to remember this number, and we will use it in the next examples. A helium balloon, assumed to be a perfect sphere, has a radius of 18 centimeters at room temperature 20 Celsius. Its internal pressure is 1 atmosphere, 1.05 to be exact. Find the number of moles of helium in the balloon and the mass of helium needed to inflate the balloon to these values. So we have a balloon, helium balloon, and it is a perfect sphere and has a radius of 18 centimeters at a room temperature of 20 Celsius, which has the pressure of 1.05 atmosphere. So we want to figure out what is the number of moles of helium in the balloon, and also the mass which it has. So we can use the ideal gas law because it is likely that it will behave like ideal gases. So let's start and how we can take this. Okay, we have a perfect sphere shape. So the volume for this balloon will be, okay, if you want to remember, we know that the volume of a sphere is 4/3 times pi r cube. And the r is 18 centimeters, so we need to convert it to meters to be in standard form. So it will be 4/3 times pi times, it will be 0.18 meters cube, which will be this number, and this is the volume of the balloon. Also, we can note that the pressure is given in atmosphere, so we want to find all of them in SI units. So we can convert it to newtons per meter square by multiplying this atmosphere. So we know that the pressure is this. So if we want to convert it, we will multiply it with 1 atmosphere. They'll have 10 to 5 newtons per meter square, which will be roughly about 1.64 times 10 to 5 newtons per meters square. And also the temperature should be in Kelvin, but it is given in Celsius. So it will be 273 plus 220 will be 293 Kelvin. So after converting all of them in the SI units, we have the formula. What was it for the ideal gas? PV equal to nRT. So we are asked, first we are asked to find the N. So here will be N equal to PV over RT, right? And if we put these numbers, what is P? P, we found it, which is 1.64 times 10 to 5. What is V? V is 0.0244. And R, we should remember R, which is a constant, universal gas constant, 8.314. I don't write the units. And then times temperature T, 293 Kelvin. So if we calculate it, we will get 1.066 moles. So we have this amount of mole in the balloon. So we're asked to find the mass of the, so we want to convert it to the gram or kilograms, whatever you prefer. So let's convert it to grams. So we have this amount of moles, so 1.066 moles. If we want to convert it to the gram, we will say 1 mole of, we have helium. Helium has what is the 1 mole of helium? How many grams does it have? It will be 4 grams. Okay. Why? Because helium has 2 protons and 2 neutrons, so it will be 4. So we can say it has 4 grams approximately. It will be 4 grams. So moles will cancel, and we will get this value, 4.26 grams. So we will have this amount of heliums, 4.26 grams and 1.066 moles of helium in the balloon. So now let's go to another example. Okay, this is the last example that we're going to solve, but before solving it, I want to talk about the fact. Actually, it is easy to know that our formula for the ideal gas is P equal to N R T. And with this information, if we move T to the other side, we will have PV over T equal to NR. N and R always will be a constant if we don't change the amount of gas. So this will be constant. And if we don't change the amount of gas in the experiment, and we just changed P, V, or T, or we can also don't change one of the variables, then we can have this relation P1 V1 over T1 equals to P2 V2 over T2. P1, V1, and T1 are the values for the initial values, and P2, V2 over T2 are the values for the changes that happen. Okay, so we have this formula which is useful to solve this example. So it says that an automobile this is a tire, is filled to a gauge pressure of 200 kilopascal at 10 Celsius degrees. After a drive of 100 kilometers, the temperature within the tire rises to 40 Celsius. What is the pressure within the tire now? So we are given pressure and temperature for the tire, but it is important and crucial to know that this is the gauge pressure. This is not the absolute pressure. Okay, so the absolute pressure is 10 to 5, or I'm supposed to say that not the 10 to 5, but we can say what is 1 atmosphere? It is roughly 101 kilopascal. This is for 1 atmosphere. I mean, the pressure near the oceans, right? Plus the gauge pressure. So, here, the gauge pressure is given 200 kilopascal. So the absolute pressure will be 301 kilopascal, right? So if we convert, not convert, let me stay here, okay? So we have this amount of pressure in the tires. We also have given the temperature, T1, T1 will be 10 degrees, so it will be 273 plus 10, which will be 283 Kelvin. And T2, after going 100 kilometers, it will raise to 40 Celsius, so it will be 273 plus 40. It will be 313 Kelvin. Okay. The volume will not change. So V1 equals to V2. So this is the same tire. So the volume will not be changed. So the formula we will have will be P1 over T1 equals to P2 over T2. Right? We have the P1. This is the P1 that we found the absolute pressure. And we are asked to find P2. So we have P1, we have T1, we have T2, we will easily find P2. And if we write it, P2 will be P1 times T2 over T1. And if we substitute these values that we have got, we will get 333 kilopascals. So we will have 333 kilopascals. And as you can see, we have increase in the pressure. P1, P2 is higher than P1. So what was the relation that we had before? It was the P times V is proportional to the temperature, right? If we increase, if we have volume to be constant, and if we increase the temperature, as you know, we increased temperature from 10 Celsius to 40 Celsius. And if we increase the temperature, the pressure will also increase. So that's it. I hope that this video was useful to understand the ideal gases, the gases laws, and to know these concepts much more easier. Thanks for watching.